Alright, so let's introduce two other data types, or more correctly primitive types in Java, the byte and the short. Then we'll introduce a third one later on. So we're going to start by closing down the run window and click on this little option down there to do that. And I'm going to start typing after line 16, byte this time, B-Y-T-E, and we'll call it my min byte value. We're going to do the same thing we've done for integer, but for byte. We're going to make that equal to, this time instead of integer, we're going to use the word byte with a capital B and a period, min underscore value, semicolon. We'll do the same for the maximum value. My max byte value is equal to byte with a capital B, period, this time max underscore value. Let's then print them out as we've done above, and we'll put byte minimum value is equal to, closing double quote, plus then our my byte min value, and we'll take a copy of that line again, paste, and we'll just change this to maximum. Then we need to change the variable on line 21 to be max as well. Alright, so let's run this and we can see what the minimum and maximum ranges are for a byte. Now you can see that in that case, for a byte, the range is quite small. The minimum value you can go down to is minus 128 and the maximum value is 127. So the range is quite small, and frankly you probably won't be using the byte data type a lot. Now maybe if you had a requirement to store a lot of numbers that are within that range and you want to save memory, but also it could be a good idea if you were doing that to use the byte instead of say an int if you wanted the fact that there were a small range documented. So using a small data type is actually code documentation in the sense that someone would read the code and then note that you're using a data type in this case that is quite small and that there was a specific reason for it. But with that said, today's modern computers mean that you perhaps can be a little bit lazy with memory and not worry too much about space and how much is being used. But keep in mind there can also be performance reasons that come into account. A smaller data type takes up less space and can be quicker to access. But in general, another thing you probably won't affect you much due to the speed of today's computers, but certainly was a factor when Java was first created. Right, so that's the byte data type. So let's create another one now. The next one we're going to look at, the next primitive type, is our short value. So let's do the same thing with that. We're going to select that. I'm taking a copy of the 4 lines there and I'm going to paste the code into there. Alright, now we've got an error there and that's because we're reusing the same variable names. So let's actually use the search and replace functionality built into IntelliJ to make these changes for us automatically. I'm going to go to find, replace. Alright, so I'm going to, first things first, I'm going to change byte with a capital B. I'm going to change that to short with a capital S. So I'm going to make sure that to match case is checked there. So we're only updating the ones that match precisely with case. Replace all. Then what I'm going to do is come back here and replace byte with a lowercase b with short with a lowercase b and do a replace all for that as well. And that should be our code change. So basically we've just swapped out the word byte for the word short. We should be able to now print out those values. So let's do that and see what range a short can contain. We can see the short minimum value is minus 32,768. The maximum value for a short is 32,767. So both the byte and the short have the same overflow and underflow issue, but obviously with their own range of numbers. So let's have a brief talk about how much space each of the data types we've talked to take up in memory. Right, so I want to talk about the size of primitive types and what width means. So a byte occupies 8 bits. Now a bit is not directly represented in a primitive type. We have a Boolean, which is not really the same thing that we'll discuss in a future video. But we can just assume that a byte occupies 8 bits. Now we can say therefore that a byte has a width of 8. Now a short, on the other hand, we saw that it can store a larger range of numbers, and for that reason it occupies 16 bits and has a width of therefore 16. Now an integer has a much larger range, as we saw again compared to the byte and the short. Well, that occupies 32 bits and has a width of 32. So the point here is that each primitive type occupies a different amount of memory. We can see that an int now needs 4 times the amount of space that a byte does, as an example. Now, it's not particularly relevant for you to know these numbers, but it's something that could come up as an interview question, and it's useful to know in general that certain data types take up more space than others. Alright, so there's one more data type, and that's of use where you've got a number that you want to process that's larger than the amount for an int. So we call that one the long. So let's go ahead and add some code for that. So we're going to type long, my long value is equal to 100. Now technically what I've done there is wrong, because when you're assigning a long value, you need to put the letter L on the end of it, and that tells the computer that it's a long value. So we can go ahead and do something like this. We can put an L there, and you can see that if we hover over it, long literal ends with lowercase l, and it actually tells us that could be confusing as lowercase l looks very similar to a 1. So for that reason, when you're doing it, I suggest you always use the uppercase L to make it clearly stand out as we've done here. So the long has got a width of 64, which is obviously double the size of an int, which we established had a width of 32. So it means it's double the width of an integer. So the actual number we can store is huge though in a long primitive type. It's actually 2 to the power of 63. So let's grab the code we've done for short and do a similar thing that we've done previously. We're going to copy it. I'm going to paste it under our long definition, our declaration for my long value on line 28. And we'll do a copy, search and replace there. Now it's Control R, we saw last time with the shortcut. So firstly I'm going to do short and replace that with long with a capital L, making sure match case is selected, replace all. I'm going to do the same for short as well, so short to long, same thing there, replace all. Alright, so now that we've done that, let's just close down that search and replace, and we'll right click and run this. And let's see how big the range of numbers can be. Now if I just scroll this up a little bit, contrast that to the size of an integer, and it's significantly larger, as you can see. It's a pretty big range of numbers there. Now yes, it has got the same type of overflow and underflow problem we've discussed for the other primitive types. Now I'll just minimize this again, we'll go down and we'll close it off. So by default, Java considers a number you type as an integer unless you add a letter on the end, as we did on line 28. This forces Java to treat that number as a long. But you might be wondering though why the long declaration worked without an L. After all, when we first started, we didn't put an L there. And you can see clearly we haven't got an error on line 28 by removing the L. Well, the reason is that an int fits fully into a long, because obviously a long is twice the width. So Java is smart enough to know that and just converts the int to a long for us instead of giving us an error. However, if we try and type in a literal value for a long without the L, we will get an error. So we know previously we've used the maximum range there. So if I copy this maximum int test number there, which we know was the maximum number. So if I come down here and create a new variable, we'll call it long, big long literal value, equals, firstly if we do that, put a semicolon there, that works. We know that that's the maximum integer number, and so IntelliJ is quite happy to accept that. But if we change that and put an underscore 234, suddenly we've got an error there. And we can see there, that's the hint, integer number is too large. So clearly Java is telling us that it's still treating that number as an integer. And you can see that's why the default whole number is an integer in Java. So we put an L on the end there to treat it as a long, and you can see suddenly that number has been accepted. And just to confirm that, we can then print that out. Let's go ahead and do that. Do an S out, big long literal value. And we run that code. See down the bottom, our largest number clearly is correct. It's got the 234 on the end. And I'm not going to attempt to read that number out. Now just before we finish the video, Java's also smart when it comes to converting numbers from int to say a short. So it knows if the literal value we're going to use is not going to fit into a short. So to see what I mean there, if I add this code, if I type in short, big short, literal value is equal to 32768, and we established that 32767 was the maximum number, and we can have a look at our code there. Maximum value, short maximum value is 32767, so clearly we've got an error there, and it's saying incompatible types required as short, but found an int. But if we change that to a 7, which we know is valid, the error's just disappeared, and Java is quite happy with that because it knows even though the number is an int, which potentially is larger than the maximum that can fit in a short, in this particular case, the literal number we've entered doesn't exceed that and it can actually fit directly into a short. Right, so let's finish the video here, and in the next one, we'll start talking about a bit of arithmetic using these data types, and then we'll talk about another important concept called casting. So see you in the next video.